Hey everybody! This video, I'm doing it at home and my dogs just got really excited whenever I started talking because I've been quiet for the past 30 minutes. Anyways, in this video, we're going to be talking about trig function transformation. See, there's Cora, she got really excited. Yeah, I got super excited when my dad started talking and I'm like shadow dog right now. Yeah! She doesn't look too happy. You're yawning? You're tired of me already? Fine, dog. Anyways, back to your regularly scheduled pre-code video. We are going to be moving around our trig functions. And lucky you guys, you're only going to have to be able to move around sine and cosine. Back in the past, we were like super hard on them. And we were like made them do sine, cosine, cosecant, tangent, cotangent, and cosecant. So all the rules apply. Everything applies. So if you get to a course later on that you have to move around those values as well, those trig functions, it's the same sort of stuff. So big thing to keep in mind is to follow your order of operations. Follow your order of operations. So what that means is essentially PEMDAS. We'll do anything inside the parentheses. That doesn't really apply. We don't do any exponents. That doesn't really apply. So essentially what I want you to know is that we're going to do any multiplication and division before we do any addition or subtraction. You may have been taught, I think Miss Dodson uses, if she still teaches here, Senior's Rule Marcus, SRM, which is also Mrs. Backwards, which is how I used to teach in the past. But what I do now is I just do any multiplication or division. So notice we have a 1/2 here, right pen, a 1/2. That is kind of, it's not with my x value. So what this does is, since it's not with the x, it's going to affect our y direction. It will multiply the y's by 1/2. So let me go ahead and get our parent function on here, our parent function of sine on here. So there's our parent function for sine. So what I'm going to do is I'm going to take all of the y values and multiply them by 1/2. So this point right here has a y value of 0 times 1/2 is still 0. This y value is 1 times 1/2 is 1/2. 0 times 1/2 is still 0. Negative 1 times 1/2 is negative 1/2. 0, negative 1/2, 0, 1/2, 0. So just after multiplying our y values by 1/2, we have a graph something like this, so that it is 1/2 the size. All right, next thing that we see, I have on the inside a negative 1 multiplying my x. When we're with the x, we'll do the opposite of what we see, but if we take 1 and we flip it, it's still 1. So really all I'm going to do is multiply my x values by negative 1. I'll keep the y values the same. So 0 times negative 1 is still 0. Pi over 2 times negative 1 is negative pi over 2. Likewise, negative pi over 2 times 1 is pi over 2. So essentially what this does is it reflects it over the y-axis. So that will stay there because negative pi times negative 1 is pi. This will move all the way over to negative 3 pi over 2. Negative 3 pi over 2 will move to 3 pi over 2. So I'm reflecting everything over the x-axis. So once I do that, it will look like this. Yeah, I didn't know I was already showing you guys that video. Sorry. So in the green, yeah, you already saw that. That was the x values reflected, so the reflection over the y-axis. Now I'm going to take every point, and this minus 2 here, that takes every point and it moves it down 2. Again, since it's not with the x, it does it in the y direction. So if I take this point, move it down 2, take this point, move it down 2, 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 down 2. Yes. And then just connect the points. Oh, so pretty. Oh, yeah, so pretty indeed. Oh, yes and yes. So make your final graph very obvious to us, or right on here, that is my final graph. Whatever you want to do to help us make sure that we're grading the right one. We know what you are doing altogether. But this is what our graph would look like after all the transformations. So after we have multiplied the y's by 1/2, the x's by negative 1, and we have moved the function down 2. All right, let's look at another one. All right, this one. Again, remember you multiply and divide first. and then we'll add and subtract. So here my parent function is cosine, so I went ahead and I graphed my cosine function on there so that we can move that around. Now notice, I have an x divided by 2. If we are inside with the x's, just like when we're moving left and right, we kind of do the opposite of what we see. So instead of dividing my x values by 2, here I'm going to multiply the x's by 2. So it's actually going to stretch it out some. So if I take my x value, so like this one's 0 times 2 is still 0. Pi over 2 times 2, well that's 1/2, so that would be like 2 pi over 2, which would just be 1 pi. If it also helps you, if you think about this, this is 3 spaces in the x direction. 3 times 2 is 6, so now it's 6 spaces in the x direction. Pi times 2 is 2 pi. Same way in the other direction. So just after multiplying my x's by 2, it really elongates this function. So that right now we have something that looks like that. Last thing we're going to have to do is take everything, move it up 4. So I think I made a mistake and it's off my graph a little bit, but it's okay. It's okay. It will all be all right. So 1, 2, 3, 4. Let's put it right there. Sure, that's 5. 1, 2, 3, 4. 1, 2, 3, 4. And 4. And 4. All right, so we would have a graph. I think I'm a little bit off, but whatever. You get the point. Hopefully. Hopefully. All right, and again, make sure you say final or something like that so we know what you think the graph actually looks like. Yeah! All right, so we have here 2 cosine of x plus pi over 6. So again, I'm looking for any multiplications. I went ahead and I graphed my parent function of cosine. Cosine starts at 1, 3 pi over 2, it goes down or it goes up back to 1. So here I have a 2 on the outside. So what that does, that's going to multiply our y values by 2. So 1 times 2 is 2. 0, negative 2, 0, 2. This is essentially affecting the amplitude. The amplitude is how high the graph goes, how high or how low. Can you go? Right? But essentially from 0, from kind of the average of all of the points, it goes 2 units up. That is the amplitude, how high it goes. So just after multiplying the y values by 2, I have a graph that looks something like this. Oh yes, so pretty. And then this minus pi over 6. Remember with our x value, it's going to move in the x direction. Oh, sorry, Cora, I just kicked her. Didn't stand on my feet. So I'm going to move left pi over 6. And if, check it out, there's 1, 2, 3, 4, 5, 6 lines in order to get to 1 pi. So that must mean each line is pi over 6 on your graphs here. So if I move left pi over 6, 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 left pi. All right, so then connect the lines. Oh yes, so pretty. Now I like to turn my paper sideways so that I can get the other nice curve there. Beautiful. Oh, yes. Going back down and going back down. Oh, that's blank. That one's right. So again, in the purple there, you have your final graph. Or it looks like blue. It's supposed to be purple. Maybe if I get closer with it. No, it still looks blue. All right, looking at another. Oh, yeah. All right, let me go ahead and get the parent function on here, save a little bit of time. And here we go. All right, so again, any multiplications. So I notice I have a negative on the outside. So what that's going to do is it's going to multiply our y's by negative 1. So if I take that at 1, it's now times negative 1. Zeros will stay 0. Negative 1 times negative 1 is 1. 0, negative 1, 1. Cool, I can reflect the beam of light. Oh, but you guys can't see that. All right, so just multiplying the y's by negative 1 essentially flips it over the x-axis. It's a reflection over our x-axis. So we have a double helix, dude. Cool. Cool. Totally tubular. This 2x, remember, do the opposite with your x's. So instead of multiplying by 2, we're going to multiply our x's by 1/2. So if this is at pi over 2, 1/2 would be at pi over 4. Notice also it's 3 lines. Half of 3 lines is 1.5 lines. 0 would stay 0. Pi would be here. So now, check it out. We kind of have our base pattern set up. Notice it goes down 1, and then over pi over 4, it goes over 1.5 lines, then it goes over 1.5 lines. So this 3 pi over 2 is now at 3 pi over 4, and then it's going to go back down, and it's going to go down. Once we're at the bottom, you go back up, and it repeats this pattern in both directions forever. Jeep, 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 chirp, 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 gerbil, 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 gerbil. Right, and we'll do the same thing on the other side. And then you're just going to take all of your points, move them up 1. So what that's going to look like, this point is up 1, up 1, up 1, up 1, up 1 everywhere. Let me go ahead and do that real quick so I don't waste y'all's time. That our final graph will look something like this. So please, please, please remember, if it's inside with the x, it does the opposite, and then follow PEMDAS. Make sure you guys multiply, divide, and then you add or subtract. So something like this, the only thing it's doing is moving left pi over 4. Just so you guys know, from here to here, that is 1/2. Well, pi over 4 is half of a half, so the distance pi over 4 is over kind of like 1.5 of these spaces. If you had pi over 6, like we talked about, is just one of the spaces. So if you had something like pi over 3, well, if we go 2 pi over 6's, that reduces to pi over 3. So pi over 3 would be like 2 lines here. So like if you saw something like this, sine of x minus pi over 3, that would just move our sine graph to the right pi over 3. All right, I hope this video has been helpful for you guys. As always, please, 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 please come ask me questions. That's what I'm here for. Yeah, go ask questions. Right, Cora? Oh, now they're just laying on the couch. Bums! Lazy bums, they're not asking questions. All right, I'll see y'all soon. Bye-bye!